Hi everybody, Jeff Simon here from SocialFlight down in Mobile, Alabama at Continental Aerospace Technologies. I'm here with Oliver Lieber. How are you doing, Oliver?
Good, Jeff. Thank you. Thanks for coming.
Oh, I really appreciate it. Oliver is Vice President down here at Continental, and I'll tell you, it's been 5 years since I came down and visited the factory here. At the time, it was called the Blue Marlin Project, because this was still in the works when you were converting from the factory. I hate to call it the old factory, but it was like the factory that was legendary for producing so many engines for so many decades, to this amazing new facility. And a lot of this was empty at the time, and now it is completely full, up and running, making state-of-the-art engines, parts, and everything that keeps so many aircraft running in the fleet. Tell me a little bit about why we're here and the 120th anniversary for Continental.
I can't believe it's been 5 years. Yeah, absolutely. And a lot of things have happened since then. Yeah, we're celebrating 120 years. This is our building now. This is our factory. This is our headquarters here in Mobile, Alabama. And I'm sure you're going to see a lot of changes 5 years ago versus now. The factory is full. We invested heavily into more equipment, a lot more machining going on. They're running around the clock. We're producing parts. 120 years, it's a long legacy that we're going to carry forward.
Yeah, and we're going to take people through a tour, let you see that factory. But I'll tell you, it's really amazing just from up here and peering out on the floor and seeing what's happened. And you know, in that time since I was here, we went through a global pandemic, went through some very serious supply chain issues, global issues that are really going on. And I've been incredibly impressed at how Continental has delivered during that time in terms of product availability. Pricing has remained reasonable and at least approachable for people given what's happened in the rest of the general aviation market. And you can get parts. That's not really true of all the competitors that you have in the field. This is unique to you. How much of what you've done here with this new factory played a role in being able to support both through that time and onto today?
Appreciate the comments. And yes, it's tough times, right? We've been going through a lot. If you think about 120 years, the tailwinds and the headwinds we've had, the ups and downs and all the challenges, I would say a lot of the successes on the parts is a result of this factory, right?
Yeah.
I mean, there's the efficiencies of the machinery, the throughput, the quality, everything that we're producing here is a direct result that leads into delivering parts to the customers.
Wow. It's so helpful. And again, for anyone who's watching this, you can go back and see that video where we show a lot of the things that were being produced in the older factory and how manual many of those processes were, and then how at the time we were just beginning to see how cylinders and other parts are being made in this factory. But now you're doing CNC machining, having to do with cases. You're doing there's so much happening that it's really fantastic. And so I love this celebration of Continental's 120th anniversary, but really combining it with a tour. So we're gonna get in there and take a look around. What are a couple other highlights before we get down there?
Well, I would say again, in the context, 120 years, you put it in context, right? The Wright brothers were 2 years before that. So it's a long history, but yes, you see the equipment we invested in, 5-axis CNC. I mean, brand new, state of the art.
Yeah.
And again, that really is a true kind of investment to our commitment to the industry and carrying that legacy forward. So.
Well, it's really great. I am certainly grateful for everything that Continental does for the industry. You also support SocialFlight, of course, which makes all these events, destinations, and education available to everyone at no cost in the industry. And that is, it's just really wonderful. I'm also looking forward to a big gala event that we have here with some key people from industry, from manufacturing, from government, all coming down to celebrate what you contribute to the community and the industry. It's going to be a lot of fun, and I'm honored that I've been chosen to be an MC for that event.
Wonderful.
So,
we look forward to it.
Yeah, we're gonna have a lot of fun. So let's go down on the shop floor, take a tour around, and show you a little bit more about what's happening here at Continental Aerospace Technologies. I'm here with Amber Fall. How are you doing, Amber?
Great, yourself?
Well, I'm really excited to go in and take the tour. It's been 5 years since I've been here. At the time, it was Blue Marlin as the project code name. Took a tour of the old facility, and then we're just getting started here, putting in all the new equipment. So I'm really excited to follow along with you and get to see some of the CNC machining and the cylinder manufacturing and all the cool things going on here.
Yeah, absolutely love it. Can't wait to show you.
Absolutely. So let's get started. We'll put on our safety glasses and head on in.
Okay, sounds great. After you.
Thank you.
Okay, so to go ahead and start, we're going to start at the Niles, which is going to be our crankshaft milling machine, and I'll go through some of the details and what the actual cycle is going to end up looking like. So this is going to be our Niles CNC milling and drilling machine. Something very unique about this particular machine is it's going to take about 3.5 hours or so, depending on the crankshaft. And it's going to go from a raw forging, which I'll show you in just a second, all the way to our finished milling and drilling processes, which is actually most of the machining that's going to end up happening on the crankshaft itself. So we're going to have our forging. It's going to start at about 105 pounds. It's going to go down to about 90 or 95 pounds depending on the part. We're going to go through a couple stress relieving operations, and then we're also going to go down to a grinding and finished machining application, which you'll see here with tin plate. We've got a 6-cylinder and a 4-cylinder that's here on display. But this specific machine, from the forging to the milling and drilling, everything actually does take place on one machine. The milling operation with that large wheel is going to cut all of that scrap forged material off before it goes into a stress relieving cycle. Yunker is going to be where we're going to do all of our grinding operations, and that's going to be also very unique in the fact that it's going to be doing our crankshafts and our camshafts. And what I mean by that is that most CNC centers aren't able to do multiple families. They're only able to do one type of part family. And in this case, we're actually able to separate it and do two. So with both the crankshaft and for the camshaft, crankshaft is going to take about 45 minutes and camshaft is going to take about 7 minutes. So looking at our camshaft processing, we're going to start already here at the forgings. So we're going to go from forgings to our milling and starting the drilling operation. Then we're going to end up going and applying copper, and then through a hardening process. The hardening is only going to harden the lobes, and that's the purpose of the copper plating. And the black that you see here is going to be our manganese phosphate, and that's going to end up being the process for rust prohibitor. And throughout the entire life cycle, it does take a little bit of different time for each of the processes, but at the very final stage, this is what you're going to see for a final finished product. So on this RGV cell that we're looking at for the crankcase Mazak machining, this is what's considered a tool hive. And on this particular tool hive is one of 4 that's attached to the RGV. And it's going to end up having, if you go ahead and look all the way down, we are still in the PPAP approval process, so not all of the tool bits have been loaded just yet. But we do have all the way up to 506 options of being able to put all of the tool bits into it. So what this is going to be doing is it's going to allow us all of the machining characteristics on all of our families of crankcases. So what you'll be watching here is going to be our coordinate measuring machine, which is also called the CMM. And what this is going to be doing is counting and pointing to different spots in space and measuring that to a 3D model. There's going to be multiple spots that this is going to be detecting. It's actually going to be over a couple thousand, as a matter of fact. So as it's going through and detecting where it is, it's going to be showing us whether it's green to the model or whether it's going to be red. Red meaning that we need to have an area of improvement. And then from that information per crankcase, it's going to start collecting all of the data together to see whether or not we have any type of anomalies that may be needing to be adjusted as far as a full process, so that way we can hone in on any key characteristics.
All right, Amber, this is one of the coolest stages or parts of the manufacturing facility for probably any pilot or aircraft owner, or probably even mechanic, because Cylinders are so tangible, right? We see them every time we pre-flight. They're part of everything that we touch on an engine. And show me a little bit about the evolution of a cylinder here in the factory.
Okay, absolutely. So if you look here, we're going to have our cylinder forging. And if you pick it up, it's going to weigh a substantial amount.
Oh my God.
It's going to weigh about 32 pounds. And then after it goes through our CNC machining center, which is going to take about 7 minutes or so to go through all of the machining characteristics. So as you can see here, we have all finished features, much lighter, if you want to try holding that one.
Ooh. So this turns into this.
Correct.
This looks like a piece of jewelry. This is like artwork. And it turns right into that.
That's right.
All through the machine. That's impressive. And it's all CNC'd and then quality checked because of that. And then what happens after this?
So from here, we're going to end up going to our machined head, which you see on display.
Is the barrel treated in any way first or anything else before it gets there?
Not to this point. So what we're going to end up having is just the raw forged barrel that's going to be machined, and then we're going to have our casted cylinder. And if you look on the inside of the cylinder, here you're going to see all of the threading on both sides for the head and for the barrel. Now what you'll end up seeing is going to just basically be, both of them will be coming together through the machining process, and that's going to be on our CNC center. According to our design, just to speak to that just a little bit, there's actually going to be a bit of a gap in between all of the grooves that you see. And with the oven expansion and then tightening, that groove is going to go away.
Right.
So what we'll have is a nice tight fit. So the two aren't actually held together with any type of glue or screws or anything like that. It's just the sheer compression.
This is the interference fit that we all hear about when it comes to cylinders. You heat the head, you chill the barrel, they get screwed together in the right way, and then when it stabilizes, might as well be one piece, right?
Absolutely, that's correct.
Yeah, and the whole goal is for this, where the piston rides up and down, the piston rings, to be the most durable possible, and yet the head to be lightweight with all the mass that it has, and have the fins that distribute all of that heat. And then of course, this is where all the complexity is, the valves, and the valve guides, and the springs, and the rotators, and everything that goes into all this. So all of this turns into a cylinder.
That's correct.
Perfect. And would look great on my desk. I'm just saying. Just saying. Would look good. Excellent.
So what we're looking at right now is going to be our engine assembly staging, and you have a very full table, as you can see in front of you. Lots of pieces that look as though it might be a giant puzzle, which in a sense it is. So we're going to be assembling all of the pieces of this puzzle together. There's over 540 components, really more like about 1,000 and change without going into too many details. So we're going to start at the very beginning of the engine assembly line, and what we'll be doing is putting together everything that's going to go on the inside of the crankcase. So what you'll see here is going to end up being our crankshaft and camshaft, and as we continue to move down the line, you're going to start seeing the gears and the connecting rods and everything else start getting assembled. They'll get placed inside of the crankcase, and then from there, everything's going to start being built on the outside. And as we continue to move on down the line, you're also going to see more details related to potentially the stringing of the crankcase, etc. So what we're currently going to be looking at is going to be the crankcase after we've started assembling it. So if you look here in detail, you're going to see the silk thread where the crankcase has been joined together, and what that does is allow for a nice solid joint with still allowing the mating surfaces to be able to touch each other. You're going to see our crankcase and camshaft and connecting rods, everything that's going to be pointing out in order for us to allow for the cylinders, etc., to be applied. And also you can see that the table itself has now changed. So with this, we're going to be able to allow it to be able to rotate, as well as allowing for 2 team members to be able to work on the same operation at once, which is actually going to be required depending on what particular operation that they may be working on, to make sure that we have everything working in unison. In addition to this, throughout the operations, we also do have DC tooling and electronic controls to make sure that we do have the proper torques and the proper sequencing on the bolts. And as we continue to move down the line, you will end up noticing that you can start seeing more and more of what would be a completed engine starting to form. So you'll see here we've still got the cylinders that are still exposed, so we don't actually have the rocker covers that are going to be applied just yet. We're also missing all of the exterior accessories such as the fuel manifolds and things of that nature that would also be added to the engines. And again, back to the rotating, there are different times where we do need to make sure that it is in a different position depending on what we do have to apply to the engine. So this allows for a better ergonomic fit for the team members. Now we can start seeing the oil sump and everything being applied. Throughout the operation, it's going to end up taking anywhere, well, it would take an average about 7 to 8 hours to go down the entire engine assembly line from point A to point B, depending on which model spec that we'll be having going down. So we do have a completed engine staged here. However, if you notice, there's not a whole lot of additional engines that are staged. We have more that are staged that have just come out of our dress out bay. We have multiple staging areas depending on what type of engine specification that have come through. We have about 40 of them that do go through our dress out bay, about 60 of them that do not. Meaning that once we end up having it coming out of either location, it does have to go through our quality inspections. And every engine that comes through does have to go through that same quality inspection step. Okay, so the engine that we're looking at is going to be one of those examples of the engines that have to come through the dress out bay. So starters, alternators, turbos, lots of smaller detailed and very high intricate items would end up being applied here in this stage. These are all going to be elements that are not going to be on some of our other engines depending on the specification that's ordered.
All right, Amber, so we've seen a lot of traditional gold-colored engines that we think of as classic Continental, IO550s, IO520s, 470s, 360s, those ones that are like originally there. But you've got an experimental market as well, and those are, tell me about the one we got here, the Titan line, basically.
That's right. So this is going to be the Titan line. As you can tell, it looks significantly different than it does for our Legacy or for our gold and black colored scheme engines that you've been seeing here so far. The way that we have it mounted is completely different, and as well as the induction tubes that are on top, they're actually going to be flipped differently than what we're going to see typically in our Legacy line. So this particular setup, we are going to be having as our 4-cylinder stationary 340, and we are going to have other models as well, but they are going to be very typical of this. What's also unique is that we can get all different colors that's going to be available for it, and that's going to be up to the individual consumer. So if there's somebody who wants to have something that matches their airframe, totally available for you.
Right, so if you're looking for experimental and the more traditional kind of like 4 cylinders that are experimental versions of another type of brand but made better by Continental, then take a look at this Titan line, and you've got this manufacturing line happening in the same facility.
Absolutely.
Very cool. Okay, so Amber, one of the really cool things about this facility and where you're going with this is that the kind of old school method of putting a club prop on to an engine to get it running, to do those very few hours before you ship an engine, which all engine manufacturers do, is a big part of the process. Make sure there's no leaks or other problems going on. But that's always traditionally been done in that old school way. You're going to be doing it now with whole new technology in this factory. Can you explain a little bit about what we're looking at?
Yes, absolutely. So as most people would be more familiar, there's going to be a prop that would be mounted to the engine, and instead of having a prop, we're going to have a motor that's going to end up driving the engine as far as starting it is concerned. And it's also going to allow, with the prop, what it would be doing would be allowing air to be able to flow over the fins to allow for cooling, and instead we're going to have it as air induction. So what this is going to do is going to be blowing cold air onto the engine as it's going through the test cycle. And differences that we would also be able to account for is going to be not having to worry about the heat from summertime or the cold from winter, the humidity, and lots of other environmental factors that's going to allow us to be able to better test the engines in an enclosed environment such as this.
That seems like a huge advance, actually. The idea, if you guys aren't familiar with it, I mean, look at how most engine overhaulers or manufacturers do things. You get this big club prop, you've got a shroud that just pushes some air over this. You're doing it all controlled. You're going to be controlling the airflow over the fins. You're going to actually have a dyno that's going to be on there, so you actually know the power output.
That's correct.
Of the engine, which is something, again, isn't normally being measured when you get your engine overhauled or a new engine from a different manufacturer. You don't usually know exactly what it's doing, and so that gives you a unique opportunity to detect anomalies early on in the process.
Absolutely, long before it actually gets shipped to you.
That's great. Very, very cool. So Amber, one of the things that I think is really interesting is I don't believe a lot of people realize that it's not just the core engine like cylinders, crankcase, cranks, and cams that Continental is actually manufacturing inside this facility. It's actually all these accessories and components that go into it, whether it be fuel or electrical system. Talk me through some of these things. For example, I had no idea the actual key switch assemblies were being manufactured here.
That's absolutely correct. The same thing goes for all of the harnesses. We have tack drives, alternators. We've got multiple assemblies that are still being manufactured. There's over 20 plus assemblies that are still done. So this is just a small sample of what we're looking at as far as fuel and ignition systems is concerned.
And is that just for the new engines, or when someone needs to get a flow divider, because obviously, you know, gaskets go over time, things like that, injectors, etc., fuel pumps, or even new magnetos, they all come from here, from the factory?
That's correct. Everything, it all comes from here. As well as reman, we do have an overhaul program that's part of our sister company.
Right.
But as far as the reman program is concerned, yes, that would all be here, and then all of the factory new.
Right. So even if you go to Continental Services and you're getting, you know, an engine done, or you're getting reman or something like that, all those parts coming from what you see behind here, all the way down to magneto points.
That's correct.
Yep. All the little things done right here. That is
Lots
so cool.
of details.
Yeah. All right. Let's look at some more in the factory.
Thank you.
Well, Amber, here we are, kind of the end of the line with this amazing, like Raiders of the Lost Ark view of the inventory here. And it's really exciting. I have to say that I feel like a kid in a candy store. Like, I could take a shopping cart if no one were here and just run around and go crazy. It is amazing to see these wonderful engine parts, see everything come together. What are you most excited about what's happening here?
Oh, I just absolutely love all of the advancements that are taking place. We are currently standing in a very tall, very long production aisle for stores. And something that's very unique about this is just the fact that we're going to have pickers that are going to be locked into the floor. They're magnetic to where the team members are be able to go up and down the aisles without having to worry about conflicting with any of the product that's on the shelves or any of the guidance that may end up typically being required. So it's just really nice to see all of the advancements that the company has been making thus far.
So even inventory and picking inventory to ship is basically automated, made faster, easier, and safer.
Love it, yes.
Very, very cool. Well, it's a fantastic facility. It has come so far from the 5 years ago when I saw it just starting to get some machines put into it, and I can't wait to show you more in the future. Until next time, congratulations to Continental on 120 years. If you get a chance to come down and talk to the folks at Continental at a show or here or anywhere else, I do recommend OEM parts. I'm a huge fan of that. It's what I use on my own aircraft. And until next time, from SocialFlight, I wish you all blue skies.